This is Note Taking Guide 10.6 for Math 2. Today we're going to talk about the cross sections and a principle called Cavalieri's principle. So a cross section comes from, like, if you had this cylinder and you cut a piece out of the center of it right here, what shape would you have left? Well, this direction you would have a circle, and if you cut a section out of it long ways, you would end up with a rectangle. Those are called cross sections. I like to think about, when you're cutting like a piece of cheese off of the block of cheese, then you end up with a square or a rectangle depending on what shape the cheese is. So it helps me to remember how I'm thinking about this. Alright, so what we're going to do is we're going to just find the shape that's the cross section. If we cut the cylinder vertically like this, up and down, what shape would the piece be that I took out of the middle? And that would for sure be a rectangle. What shape would I get if I took a piece out of the cross section here, that horizontal cross section? I'm definitely going to get a rectangle. And what shape do I get when I take the cross section out of this pyramid right here? I'm going to get a triangle. So this question says the three-dimensional figure is shown with a plane slicing them. List all possible cross sections resulting from a horizontal and a vertical slice. There may be multiple possibilities depending on the placement of the slice. So if we go horizontally and cut a piece out of this right here, just right through the middle like that, this should end up being a hexagon, because the beginning shape of the top is a hexagon, and if we took a piece out of the middle, we'd end up with a hexagon. If we take a slice vertically like this, right out of the middle, I should end up with a rectangle. So here's the question about volume, and this is where Cavalieri's principle comes in. Do you think that the volume, so how much stuff can go in this stack right here, would be the same as how much this stack could hold, so inside of it? Is the volume of these two figures the same? Well, Cavalieri's principle says yes. It says that if you have the same area stacked on top of itself, which these CDs all have the same area, and they're stacked on top of themselves, it doesn't matter if you just push it to the side or move them back and forth. So one's like this, and one's like this, and one's like this. You could totally move them anywhere. They're still going to have the same volume, the same amount of volume that they can hold. So Cavalieri's principle says as long as your shapes have the same area on the base, so even this cylinder has a circle, if this circle has the same area as these other two figures, and they have the same height, then they all have the same volume. So using Cavalieri's principle, we're just going to find the volume of these. This is a prism. The volume of a prism is found by base, the area of the base times the height. The area of the base on this figure is a rectangle, so that would be length times width. And then we'd have the height of the object, which is the length in between the two bases. So the length and the width of the base of this object would be 4, and then right here we're looking for the height here, and even though they've given us the height right there, we know that that's what we're going to use. So 4 times 3, and then the height of the object would be how far the distance is between the two bases, so 6. Then we're just going to multiply those together. This would be 12. 12 times 6 is 72. So the volume would be 72 millimeters, cubed. One more problem here using Cavalieri's principle. Again, we just need the volume formula for a cylinder, and that's pi r squared h. We know pi is 3.14. We're going to do the radius, which is given to me right here. It's 2. We're going to square that and then times it by the height. So we're just going to use this height right here. This would be called the slant height, and this would just be the height. height always has to form a 90-degree angle with the base of the object. So the height will be 5 here. So 2 squared would be 4. 4 times 5 is 20. You could leave it as 20 pi if we were leaving it in terms of pi. Or that should be 62.8 if we were rounding to a decimal point number. And that will be inches cubed. Good luck on your homework, guys.